Hello, everyone, and welcome to the NL Moonshots 2024 finals. So this is a program initiated by André Kuipers, the Dutch astronaut who is celebrating 20 years of his first flight. And as enthusiastic he is about the space and sharing that with everyone, he approached Netherlands Space Office and Ministry of Education, Culture and Science and asked what can we do to engage more students into understanding what kind of space careers are coming. We already have many space careers now that don't involve just engineering or being an astronaut, and even more jobs will be coming as the space industry and space exploration is booming. So as a part of that, the NL Moonshot 24 was launched, in which students were invited to pitch their ideas, and then they're coached through a process with various experts, and even got their own astronaut to be a mentor in the final stages. And now they're pitching their final projects to all of you and the guest astronauts. So I'll introduce astronauts in a minute, but just to get you a feeling of what our students have been going through, I'll play you a movie of one of the most intense events that happened a few months ago, which was a 24-hour deep dive where they had to really polish and define their projects and their ideas, all in 24 hours with many sort of pitches and coaching and feedback. So it was a very intense, and I'd like you to see it because I hope you will feel the tears and the sweat and the blood that went into these projects.
To the moon in this decade and do the other things, not because they are easy, but because they are hard.
24 hours on the clock. Start sequence now. Houston calling. Moonshots. 24 deep dive now in session.
This is a live broadcast.
250 students deep dive into their moonshot idea for 24 hours. Welcome to the Dragon's Den. Go to the panic room immediately. Pitch your moonshot to the astronauts.
It's been a long 24 hours. Please, make some noise for Zone Blue! Our deep dive finished!
You are allowed to think bigger than ever.
Okay, so that's what they had to go through to get to this place. And as I said, this was all initiated by Andrew Kuipers. We are very grateful for that, especially in TUE, where we don't have much of the space or astronomy. I'm Jasmina Lazendic-Galloway. I am the coach for Radio Astronomy Honors Academy, which we started last year. So we are breaking through with some space and astronomy science. And we are very grateful that our students from TUE apply for Moonshot and show the interest that we can now, hopefully with this event and with the motivation from our guest astronauts, continue after this event. So as I mentioned, the student teams have gone through several phases. They were learning different aspects of creating their ideas, testing them, validating them, and learning how to pitch. And I have to say that what was very nice about the Moonshot is that we had a lot of non-engineering, non-STEM students applying. So again, the whole point of the program was to show that space is for everyone, and we're happy to see that that has been achieved. And this week we have in Nordwijk, in European Space Agency, headquarters, we have Astronaut Planetary Congress that happens every 2 years, every year. And because of Andre's celebration, it's happening this year in Netherlands, and that's why we have these wonderful astronaut guests. So, our first guest, Jen Davis from NASA. She's a veteran of 3 flights, and without me trying to explain all of her accomplishment, we'll just ask, what's the most amazing experience you bring from being an astronaut?
Well, it's hard to pick just one experience, but the reason we go to space is to do things in microgravity that we can't do on the Earth. And so if I could sort of answer it in 2 parts, for me personally, going to space to do science was the most rewarding thing, to help people on the Earth by doing experiments in space, by sending other things robotically into space. We can do things that help people on Earth, and we have direct results from those experiments and those things that we deployed on the space shuttle. For me, International Space Station, they also do experiments. So for me, doing things to help people on the Earth was very personally satisfying. But also, overall, you have to realize that looking at the Earth is the best part, because you realize how thin our atmosphere is and how fragile our atmosphere is and how we all have the same home. We're all neighbors. And so that changes your perspective. So from a personal standpoint of how it changed me, or my favorite thing of looking at the Earth from space, that would be it.
Thank you very much. And our next guest is Ulf Merbold from European Space Agency. He's still holding a record of a German astronaut with the most hours spent in space. So Ulf, what could you share with us about your experience in space?
Well, I basically share the same experience. I was also picked from the scientific community in charge of experiments, and of course that was the focus of the work, to make sure that at the end we bring back data of high quality and sufficient quantity, such that every scientist can answer the question he has raised with this experiment. That was, from an intellectual point, very, very rewarding, also from a social point, because we got in touch with so many different people working in various disciplines: Earth observation, atmospheric physics, astronomy, and so on. But I guess if it comes to ethics, I share your view. If you experience that 90 minutes are sufficient to complete one revolution around Earth, Earth becomes more or less a spacecraft. We all are now somehow together, and no one can get out. And it's a very beautiful spacecraft, the thin atmosphere, but also all the other things you see. And what you don't see are the borderlines, so prominently drawn in the human-made maps. And then, of course, that changes, as you said, your perspective. You consider planet Earth as a home for all of us. A spacecraft may have one disadvantage: no one can get out. So we all are forced to continue flying together, and based on this insight, it is not a good idea to save differences in opinion or conflicts with military power. So it's much more smart to talk to each other and find compromises and good solutions. So, and I'd like to add, I think the result is also that we have to accept some moral responsibility to make sure that planet Earth is maintained well, such that the unborn in 100 years from now on have the same quality of life as we have it now.
That's a very nice sentiment. But can I just ask additional question of both of you, since you both talk very strongly about the experiments, and I think a lot of people don't really realize, they think astronauts just go and fly to demonstrate that you can live in space. But they're not really aware that what we have in the International Space Station and previous flights, actually it's a scientific pursuit. Could you list one interesting experiment that stayed with you sort of as the strongest impact?
Yes, most of the experiments I did on my flights were either life science study in microgravity or material science in microgravity. And the one that meant the most to me is protein crystal growth, which is on almost every space shuttle flight, almost, still being done on the International Space Station. Your body is made up of proteins, and in order to study the structure of these proteins, it's very difficult in gravity, because if you try to grow a crystal of a protein, it's affected by gravity, it's affected by the container that it's in, it's affected by contaminants on those containers. And so in space, we can grow a crystal out of solution, and it's floating. It's floating, so it doesn't have the container, it doesn't have deformation from gravity or other things hitting it. And so on my second flight, we did not know in 1994 what insulin looked like. We didn't know what insulin looked like. Most protein crystal growth experiments, we flew many solutions to try to grow different protein crystals. But because we did not know what insulin looked like, we had only 3 batches that we were trying to grow insulin. So from this solution, we were growing a perfect crystal of insulin, and we were able to do that on my second mission. So it was kind of funny because it was a single shift mission, and the crystal started growing when I was supposed to go to bed. The ground kept telling me to go to bed, and I'm like, no, I have to grow this crystal. And so I had to change some things in the experiment, change some parameters, and grew this perfect crystal of insulin. And thanks to the principal investigator on the ground and the team who made that possible, they were able to make this breakthrough in knowing what insulin looked like. And not only what the structure looked like, so what they do with the structure is they bring the crystal back to Earth. They put it through an X-ray diffraction machine and create a 3-dimensional model of what the protein looks like. So now they knew exactly what insulin looked like, which was a breakthrough in diabetes research. But also because it had grown in solution, they could understand how the crystal grew. And so how insulin is absorbed in the body by how it grows. So there were quite a few things they didn't expect to learn about it, but it was my favorite experiment because I believe it had the biggest impact of any experiment I did in space.
Thank you. That's a very nice example, because again, people are not aware that what we do in space, what you do in space, actually has immediate application on bettering life on Earth. And what about you, Ulf? What's your favorite experiment?
Well, I did so many. It's always difficult to pick one. Maybe I go into human physiology. That was also quite an interesting scientific discipline. And I think I enjoyed very much to work on the organ that controls equilibrium, the inner ear organ, because on the ground, when you stand up, it's basically an unstable position because the center of mass is on top of your feet. And when you are 1 year old, that is the time it takes from your birth until you manage to stand upright and you can work. It's a control loop that manages to maintain, let's say, stability or equilibrium. And the sensors for this measurement in the 1G Earth world is primarily, of course, the eye. It notices, of course, if you are leaned to one side, but because you can also stand upright and work in total darkness. Less stable though. That is because we have another organ in the inner ear called the otolith that depends on gravity. In fact, it's a very mechanical system, and now in 0G, you take the gravity away, and then you can study what happens. In fact, it's also relevant for spaceflight because quite a number of people who go up into 0G get sick at the end of the first day. And that is, of course, also an operational question. Can we do something in order to improve this problem, solve the problem? And to make the long story short, the amazing thing is after 1 day or maybe 2 days, somehow the brain has figured out that the data delivered from this otoliths to position control are there, but they are wrong, and the brain ignores them. And that is, of course, a very interesting question. How does it work that the brain, as a self-computing, or how to phrase it? I mean, it's a computer that programs itself and adapts to the new world in 0G, and I think it's very interesting to learn more about that. And I would perhaps add, the first night when you are back on the ground, don't miss to put the light on, because without light you are primarily lost. You need the eye, because the brain says otoliths, the data are wrong data, so we don't consider them.
That's amazing. So it sort of reinforces this idea that us humans are indefinitely adaptable. Maybe that's why we are such a successful species on Earth, for better or worse, because we can constantly adapt. But that means that you were also a subject of these experimentation. You had to wear some...
You bet. I mean, I learned...
Does it make you feel like a little mouse in a lab?
I learned to draw my own blood as I brush my teeth. So it's...
Okay, that's a new definition of tough, right? Okay, thank you for that. And we'll come back with more of your stories through public questions. But now we're going to start with our student pitches. First team, can I ask you to come on the stage?
The biggest threat to humanity in space isn't extraterrestrial life, nor comets. No, it might actually be cosmic radiation. Cosmic radiation leads to several diseases. Here on Earth, the magnetic field and the atmosphere protect us from it. But once we go to space, there's no escaping from it.
We are 4 students from Maastricht and Eindhoven, and today we're not just dreaming about space. We're building a protective shield to protect the astronauts against space radiation. We do this in threefold, working from outside to within. Welcome to our Moonshot. We're excited to share it with you.
So before we will talk about our problem, we will first, or the solution, we will first talk about the problem, and that is the cosmic radiation. It consists of 2 forms. We have electromagnetic radiation, also known as gamma radiation, and also high energy particles. And for that we have to think about alpha and beta radiation, but also highly energized ions that travel at speeds nearing the speed of light. So the first part of our solution is the outer fortress, what we call it. So that's actually everywhere where our astronauts will be living in. So that's the habitats and the spaceships. And to protect our astronauts, for both cases, we will cover them all both in a layer of water, because water is able to stop the ionized particles, which could be very deadly when coming into contact with an astronaut. We will also put the habitats under a layer of ground, because ground is very ground is very good at stopping gamma radiation, because I mean it's not entirely stoppable, but it reduces it a lot. And we will also use filaments of tungsten in our spaceships to protect the specialized equipment that our astronauts need to live.
Okay, so the next part of our solution is this customized spacesuit that combines a layer of polyethylene plastic and a circular water layer that replenishes its water by recycling body fluids. And it adds localized tungsten shielding in areas that need extra protection without sacrificing the mobility of the astronaut. And by using interchangeable layers, the astronaut can customize their suit based on the mission they are about to go on.
And while outermost protection is very important, it doesn't stop there. We also have free radicals that are originating from the space radiation, and that's where supplementation comes in. We use antioxidants like vitamin A and C, as well as protectants that are used with radiation on Earth, the Birk-Bowman inhibitor concentrate, and L-selenomethionine, as well as Q10, to make a cocktail that will protect our astronauts on the long term against oxidative stress on long space missions.
And we have a talk with astronaut Eitan Stibbe where he mentioned that cosmic radiation reminded him very much of the painting of the Starry Night painting by Van Gogh, because it is everywhere around us, but it is invisible to the naked eye, yet it's shaping the space around us.
Thank you. Can we ask our guest astronauts, what do you think about this idea?
Well, it's a very interesting idea, and it's a very big problem that you're trying to solve, because we're trying to go to Mars eventually with people, and I think part of the limiting design problem is the human. And so we need, I know you're talking about a moon base probably is what you're, also Mars, okay. But getting there is also a problem, so I think part of what you're saying, like the cocktail and some of those things, may be possible to help the human withstand the radiation as they go to Mars or Moon. But it's very intriguing. I'm curious about the water, how that would work, you know, in the lower temperatures. Are you thinking of ice, or are you thinking about, you said fluids, so it's constantly replenishing itself. So that would be a consideration, would be the temperature, if you could keep it fluid. Also, you know, in microgravity, water behaves totally differently. So the fluid dynamics would be an interesting thing to consider as you're going. The recycling water, we do that already on the International Space Station from urine and sweat and into water. So that's a good application of that. The problem on the space station is it's in 3 racks. So it's a huge facility to do that. So all of you bright people, need to figure out how to make it very compact to recycle the urine or sweat or whatever, humidity, condensate into drinking water. So if we could make it compact, we need to do that. And the tungsten, that's an interesting idea. It's a difficult metal to form. You know, it's difficult to machine. So we would have to think of some innovative ways to design with tungsten in order to do what you're doing. So I think you've addressed some big issues that we need to solve, and in a very innovative way. We still need to work out some of the details, how we'd actually do that, but you've got some very good ideas. Congratulations.
Thank you.
Would you like to add anything else?
Well, I couldn't agree more. I think what you did is actually to come up with some structured way to, in a way, qualify the various threats and also how to, in a way, I don't find the proper English word, how to do something against these problems. And from my personal point of view, okay, the Mars, of course, is our final goal in this century, but I think there's no other way than to go to the moon first and stay there for a while in order to verify all the various strategies in order to cope with these kind of threats. And that would help us to build up sufficient knowledge to find out which kind of action we could take to keep people on their way to Mars and on Mars, and also on the return in good shape and good health. So that could be the laboratory to verify all your ideas, and I think it's mandatory that we do that. Otherwise, we may run into risks we actually don't want to have.
Yeah, that's a very good.
Brilliant. We have endorsement from an astronaut. We'll ask our rector to give us some funding to erect this lab and solve the problem. Thank you very much. I'll take the microphone. Second team, can you come on the stage?
Maybe I should add one simple sense. The reason the moon is a good laboratory is actually, if things go bad, then it takes only 2 or 3 days to come home. Once you are on the way to Mars, it's not possible.
And that's something that's so important when we deal with astronauts. It's always the backup plan. You always have to have a way to save the astronauts if they're stranded. And by the way, there's a lot of talk in the media at the moment about 2 stranded astronauts, and they're actually having the time of their lives. So
Yes,
don't trust. They went for 8 days mission. They're staying for 8 months. That's like all the lotteries you can ever win in life. So don't trust the media.
That's true. They're not stranded. They're fine.
They're fine. They're having fun. Oh, sorry. Go.
So the impact of space technology in society has been immense, and the demand for European technology, space technology in particular, is ever growing. And that's why we are going to build a spaceport in Eindhoven, the brainport of Europe. But it has not always been dubbed the brainport of Europe, as can be shown by this interpretation of Vincent van Gogh in 1885. The image that he portrays here is that of a city with a predominantly agricultural output and very little industrial development. Little did he know, and the inhabitants of Eindhoven, that only 6 years later, Philips were to be established in Eindhoven by Gerard Philips and his father. Philips & Co. started out as a small factory focusing on light incandescent light bulbs. But rapid growth of this company showed that Eindhoven actually went through an industrial revolution of its own. From industrial revolution, actually the legacy became a semiconductor revolution. A lot of highly educated and highly skilled people moved to Eindhoven, and the whole ecosystem of the city, dubbed now the brainport of Europe, has made sure that companies such as ASML are world-leading companies of their own in their own field. Not only that, Brainport hosts the most successful startup ecosystem of Europe as well. Not only that, a lot of major companies such as VDL and DAF, TNO and Thermo Scientific are also here in Eindhoven. Well, why am I saying all this? Again, if you look at the map, you see that we have one of the busiest airport of Europe, the biggest seaport of Europe, and so to say, the brainport of Europe. But I see something missing. Where is the spaceport? So here in Eindhoven, there's a strong focus on semiconductor industry. And in Delft, there's a strong focus on aerospace. But why are these two separated? Well, what we would like to do is bridge those gaps. During the Moonshots program, we were guided by an astronaut who did actually the same thing. At the Montana State University, he started the own faculty of space and engineering. Through some advice, we came with the following idea. We will take the military airport of Eindhoven and we'll turn that into the spaceport. Well, how do we do that? Very simple. There are key players that are already working closely together in this region. Institutions such as academia, like Eindhoven University of Technology and the TU Delft, and ESA, for example. Major companies such as ASML or TNO, and the startups. Only by seamlessly integrating these three key players, we can make the spaceport work and push the boundaries of space innovation in Europe even further. Thank you very much.
Woohoo! Give it. Finish before time. 8 seconds left. Well done.
I can speak for 8 seconds if you want to.
You want to go first this time?
Can we have a feedback by our guest astronauts? What do you think about another launch site, another spaceport?
Well, I think the more we can increase access to space, the better. So it's definitely good to have more launch sites and more backup capability for a particular launch site. So of course you know the orbital mechanics of where you need to build your spaceport, so that's an important consideration, as well as the overflight. You know, what would you launch and what would it be flying over? Those are the two main things you have to worry about with a spaceport. But have you approached any officials about this idea? Do you know?
Not yet about specifically the launch site itself, but
Yeah.
we are actually engaging in building a space community in Eindhoven overall. So one of the things you might notice is that, for example, the event of today is already one step closer to bringing space to Eindhoven. The Skylight Conference of ESA, that happened this year as well in Eindhoven. So we start with bringing awareness to the region.
Yes, I think that's
And
a
we'll take the next steps.
very positive thing to do. So congratulations.
And Ulf, can you comment maybe what sort of maybe future of space tourism might bring to private spaceports?
Yeah, I think this is really what's going on right now, that space becomes an entity for private companies, also for young fellows who actually have an idea and take the risk to, in a way, go from university into the market in order to develop their own ideas, such that jobs are created and that sort of thing. In fact, I have seen just a little while ago a company in Germany outside Stuttgart who started a rocket driven by wax, like candle wax. And it worked fine, so maybe pretty soon they are able to offer launching capability up to 500 kilogram low Earth orbit. And I think in this respect, I encourage you to go ahead. But what I'd like to add to this fantastic idea to combine the potential of various entities, I worked for ESA, and ESA is a good example for doing that. I mean, in ESA, we have Scandinavians, Italians, Brits, people, of course, from Holland, from various places. And the good thing is they bring their brain power together and also the money. And I think this is important in order to move forward. So I think your approach is perfect.
And I would like to add that I would like a parabolic flight to Australia so that I don't have to fly 24 hours. I want 1 hour flight to Australia, please.
Okay.
Thank you very much. Can I invite team number 3? So let me restart.
Yes,
count.
so we're Team 47. We're called Unqualified Engineers. Why that name? Well, let's get straight into it. Let's say we're on a journey to Mars. It's a very long travel. It'll take many months, many years, and we might even stay there for longer. And while in space, microgravity affects our bodies and the bodies disintegrate. The body tries to adapt, but often does it wrongly, and your health starts going down. And eventually, you might get sick. So what now? We're sick, we need something. Do we have medicine?
Well, the medicine you're talking about is too heavy. We need to think about the weight when we go to space.
Well, do we have medicine B?
Come on, it expired 2 years ago when we were halfway to Mars.
Well, did we bring medicine C?
Oh, we didn't think we need that.
Well, can we produce medicine, maybe?
Well, medicine A was too heavy. Do you think the machinery, the complex machinery that we need to make medicines, can we take that?
Well, no. But we do have one of the most complex machines with us, the human body. The human body can create lots of different and complex molecules. So what if we use the body to produce our certain medicines?
Well, the body is capable of doing a lot of complex things. Even medicines that we use here in daily life are produced by bacteria, by organisms. We ourselves are also an organism, and we can produce very complex molecules. Also, our organs, we produce insulin ourselves, but some people get sick and can't do that. What if we can help the body in creating the medicines that we need?
Yes. So how do we control the body to make sure we make our own medicine and keep us healthy? Well, there are multiple ways. The body has lots of sensors, which determines how their own health is going and how certain levels of certain things are, Well, what if we control those sensors, put them in a box and give them different values? Maybe we can control what the body produces. Or we can just go straight to the signals. We have electrical, hormonal, and all sorts of signals that control our organs and then tell them what to make. What if we make our own signals? What if we amplify certain signals? Or even crazier, what if we go the genetic way? What if we take the genetic code and activate certain parts to create something, or even include some new genetic code? Imagine all the things we could do when we use our own body. We could use the factory that's already there to produce things for its own body, to keep us healthy and optimized for the long term. We can produce medicine in space on long-term missions, but we even have applications here on Earth. We can help people with chronic diseases that cannot control the body on their own. We can help them control that and make the things that they need for themselves, so they don't have to take medicine all the time and can just live a normal life. Or even better, we can optimize general human health. We're getting more and more healthy, but what if we get perfect health? What if we use these kind of technologies to actually make everyone perfect healthy? Well, that's just a moonshot. Thank you.
Thank you very much. This actually links very nice to the example you talked about, Ulf, where a brain can do amazing things. So what do you think about the idea?
I think it's a marvelous idea to use the human body as a producer of drugs or medicine, but I think you could try how it works also already on the ground. Yeah. I think to go to space, it's not a burning need in order to find out what the body can do. You can at least start on the ground to come up at least with some idea what are the limitations and what are the chances that this approach is actually efficient and successful.
So phase 0 project Earth, ground, phase 1 project space. Jan, you done a lot of experiments linked to physiology?
Yes.
Yeah.
Yes, it's a very intriguing idea, and our body is amazing, as we've talked about. And so I think using the adaptability and flexibility in our own system is a great idea to help create health situations, maybe medicines, maybe something that would keep us more resistant to radioactivity as we travel. But I agree, we need to try it on the Earth, try out some of these ideas. Also, we should try these ideas on the International Space Station, because right now we do a lot of medical research on the International Space Station using the different environment of microgravity. For example, cancer research, they're finding out that the cancer cells grow differently in space. And so they're able to do some treatments. They're developing some treatments where you don't need chemotherapy for cancer because of the way the cancer cells grow in space. So the question is, how do you bring that technology back to the ground? So yes, we should try this first on the Earth. We should also try it maybe on International Space Station or some other orbiting laboratory to see how effective these ideas are before we use them to go to Mars. But we definitely need something like that if we're going to go long distances of time in space. Thank you.
Thank you very much. So we need the spaceport to be able to launch our 2 experiments and to send me to Australia in a short time, please. So now we will take some questions from the audience. Where is our microphone box? Okay. Does anybody have any questions they would like to ask?
What does the International Space Station smell like?
Well, neither one of us were on the International Space Station, but I spoke with one of the astronauts who just returned from the International Space Station, and I asked him that very question because, it's been up there a long time with people over 20 years now. So he said it was fine. There were no odd smells, and he said it was nice because You had different modules you could go to from different countries, and each one was designed a little differently, so it looked different. And so that was, from a mental health standpoint, you know, that variety helped. But the smell was fine. I asked also about the water, the recycled water from urine, how it tasted. And he said that was fine, because on the shuttle we had iodine added to the water, and sometimes it tasted a little funny. But he said on International Space Station, the water was fine.
So your missions, you stayed in the space shuttle during your missions?
Yes. And he shuttle and so you...
Well, I wasn't on the space station either, so I'm not able to answer your question. But anyway, I spent 32 days on Mir, which is, of course, or was a fairly impressive space station also. And okay, the Russian way might be a little bit more robust than the Western mode is. Anyway, we had food, to use this as an example, in tin cans, and you could read on the label it's veggies with beef or something like that. And if you open the tin can and there is cabbage, then you smell the cabbage. But that's as it is in your apartment. But it doesn't take much time and it's all gone. So they have very efficient filters, and from this point of view, I could go forever. I mean, that is really not a big deal, the smell. Although I have to admit, once you are there for quite a long period of time, and I enjoyed the privilege to fly together with Valery Polyakov, who actually spent 438 or 438 days, I don't know the number precisely, one shot without any landing in between. And at the end, I think it is also a good day in an astronaut's life to come back home, because that is, of course, in the long run, a higher quality in terms of food and so on, as it is on a station which is kind of an artificial outpost, artificial world in a life-threatening environment. It's much interesting and fantastic to go there, but it's also nice to come home.
Always come home, that's the best. But now when you mentioned food, I have a question that I was always puzzled by. I love to buy astronaut ice cream when I go to Smithsonian Museum. And then I read that astronaut ice cream never flew, that astronauts did not like the taste. But I love it. Did you try astronaut ice cream, the freeze-dried ice cream?
I've tried it, but I don't know of anyone who flew it in space. So it was okay, but it's not anything like the freeze-dried food we take with us, at least on the space shuttle, and I think they even have a bigger menu on the International Space Station. The freeze-dried food was quite good, was very good, that we added water to. But on one of my flights, we were testing a freezer, and we were using this freezer for samples, to bring back samples, to freeze these samples. And they did not want to use it for samples the first time, so they said, why don't we fly some ice cream for you and test out this freezer? So we got real ice cream on my flight, so that was a real treat.
That's a nice treat.
I think the ice cream you had, it's a fake. I mean, it's not space ice cream. It's a, I don't know what kind of product
but it's a freeze-dried, right? So it's a freeze-dried, so it just has fat.
I agree. The freeze-dried food is good food.
Yeah.
But if you want to have real good ice cream, go to Italy.
Of course. But what I liked about it is that you just have a protein fat, water is gone, and you put it in your mouth, and then your own water kind of melts it slower. So it's a very rich taste. But I understand that we all have our taste. But yes, I agree, Italy's ice cream is the best. Any other questions from the audience? We still have about 10 minutes, which is good.
Last bit. Yeah, thank you very much for being here. I have a question, since you both flew with the space shuttle, as I understand correctly.
Yes.
Yes. What's your opinion on the discontinuation of that?
Oh,
I guess that's a complicated question.
I think it's a very sad story. I mean, this was such a powerful piece of hardware and software, and maybe it was too expensive, maybe it was not reliable enough. Anyway, I mean, the gap was really a loss of capability when only the Russians had the capability to bring people to orbit and bring them back home. Now I'm already relieved that we have now alternatives, but in answering your question, I'd like to add something you have not asked for. We Europeans, we contributed to the running costs of ISS by providing what we call the automated transfer vehicle, ATV. That was sent up to orbit with all the consumables, water, ice cream, food, underwear, spare parts, fuel, etc. 5 times. And it always worked flawlessly. And it consists of 2 different parts, one being a chamber with pressurized air. And we missed the opportunity, we Europeans, to convert it into a European spaceship, because it would not have been too difficult to add a life support system and also a heat shield or some heat protection system to bring it back. And it's, from my personal point of view, a very sad story when the Americans stopped the shuttle program, that we were not ready to provide something to replace it.
And that's something talked about a lot now, that Europe wants a capability to send the vehicle and bring it back. And so there's a lot of now tenders, as I understand, to make that happen. So we might be late, but we'll catch up.
Maybe I should add one part of it. Let's say the part without atmosphere inside. The engine, the tanks, and so on, is now utilized as part of the Orion spaceship, which is under development and has flown, I think, once unmanned,
Yes.
and may fly manned eventually in the near future. And that will be the spacecraft to return to the moon and maybe later on also to the Mars. And in this respect, it's relevant for Europe that we contribute one piece which must be there. So we are now not dispensable partners, but we are on equal level as the Americans are. So that from the European programmatic, that was an important step forward.
Yes, I'll have to say I was very disappointed when the shuttle program ended, because we had 3 perfectly good shuttles, and actually leftover parts that we're using now for Artemis, but it was a very capable vehicle. It was a good platform for a science laboratory. We flew Space Lab, which my first mission was a Space Lab. You flew on a Space Lab
twice.
Twice, and that was provided by ESA, the Space Lab module, and a great cooperative program with Europe was the Space Lab. So that was one way. We had an arm provided by Canada that we used to deploy and retrieve satellites. I deployed a German satellite on my 3rd mission with that arm. And it turned out it was not designed to dock with something like the Russian vehicle or the International Space Station, but we adapted the space shuttle so that we're able to dock with other vehicles and construct the International Space Station. So it was a very flexible machine. You could do a lot with it, a lot of technology, old technology, but nevertheless adaptable technology. So I was very disappointed. I flew on Discovery twice and Endeavour once, and I could not go see Discovery in the museum. It just made me too sad, and I couldn't go see Endeavour either. So we did it. Our country did it because we didn't have money to pay for Artemis. It was another program before Artemis, Constellation, but we couldn't pay for another mission, a large mission to go to the moon and pay for shuttle as well. So that's why it was canceled. So unfortunately, we just didn't have the resources to have those two programs. So we elected to go and build a vehicle that could take us to the moon. So we have Artemis, which should launch 3 Americans, 1 Canadian to the moon next year, end of next year, probably maybe later than that in 26. But eventually we'll land people walking on the moon. So that will be exciting. Your generation's rocket with the help, as Ulf said, about the service module provided by the Europeans. And so I've been very involved with the development of Artemis, and I'm very excited about that. But at the same time, I'm sad about Space Shuttle.
I'd like to come back briefly to the shuttle. I had also the opportunity to fly on a Soyuz capsule, and what I'd like to say is the shuttle was by far more comfortable than
in Sydney, they brought, in Australia, they brought Buran, which is the Russian version of Space Shuttle, but they never flown it. They built few and tested it, but never flown it because they were so expensive, because the tiles, when you enter, they're very expensive. Because they had a method that worked. It's old, it's very uncomfortable, but it just works. So.
But they had it in orbit once, unmanned.
Yes, they had it once, yeah. Okay, so we'll now go with the pitches from our student teams. As I mentioned, the TUE is not known for space, but luckily we have young students breaking the ground. So we have 2 student teams, one formed in 2021, one formed last year, and they're going to pitch us their ideas and how they're going to bring TU into space on top of our moonshot. So Void, can I ask you to come on the stage?
Hello, everyone. Thanks all for being here. I'm Shad. This is Kaspers, and we are board members of Void Propulsion. So, as was mentioned several times before, this area of the Netherlands has lots of very fascinating technologies, and aerospace is unfortunately not top amongst them. And for students like ourselves that are very interested in aerospace and rocketry, it's a bit disconcerting. Like, what do we do? Well, what we did is we started our own student team, Void Propulsion. We are a 28-member strong team across 13 nationalities, and we are united under the mission of pushing the boundaries of aerospace here by creating launch vehicles that will democratize, reduce the cost of, and mitigate the environmental footprint of space travel, with the vision that space exploration should be accessible and sustainable by reducing launch costs and mitigating environmental footprints. But now we get to the real interesting stuff. Last academic year, we designed, built, and tested our first rocket engine, Nova 1, which is a gas, oxygen, ethanol propelled engine. And we actually test fired it on campus twice. The first time, well, the photo's very dramatic, but it was actually, yeah, we had an issue with the ignition system, so it's essentially a giant flamethrower. But we figured out what the issue was, and for our second test fire, we managed successful internal combustion. We ended up switching out our ignition system, so we make sure that the fire stays in the engine this time and not out of it. But that was a very brief intro on what Void is and what we've done to this point. My colleague will now talk about our very exciting future plans.
Yeah, thank you, Shad. Yeah, as we mentioned, we want to land rockets and make reusable launch vehicles. So there are several steps we need to take beforehand. To achieve this, we have 2 projects going on. One of them is Project Ignis, and it is a bioliquid propellant rocket that we're going to launch at Euroc, which is a competition in Portugal, which brings student teams from all across Europe together. They compete in rocketry challenges, and the category that we're competing in is the 3-kilometer one, which means we're going to have to launch a rocket to 3 kilometers exactly. For this, we also need to develop an engine, and we want to do that by the end of 2024, so we don't have much time left. And moving on from that, we also want to test the rocket itself sometime in June or July next year. Here you can see a nice render of the engine that we're developing. It is Nova 2. You can also see it in my hands right here. After several months of, this has been in development for several months, and we've recently sent it out to be 3D printed. due to its complex geometry, it needs to be 3D printed, and we should be receiving it very soon. And it's very exciting to finally be able to get our hands on it and start the testing campaign. I'm going to go dive a bit deeper into the specification of the engine. It is ethanol and it is powered by ethanol and liquid oxygen. The thrust is 1.2 kilonewtons, which should be more than enough to get us to 3 kilometers. And this engine will also be used for future projects as well. Since rocket engines, when they're fired, they get extremely hot, way beyond the point of the way beyond the melting point of metals. We need to cool it, so we're going to implement regenerative cooling, which basically we're going to pump the fuel itself through the walls of the engine, and hopefully it doesn't melt. And in the future, we're also going to implement other functions for the engine so that it can work with more complex rockets as well. So that kind of brings me on to the second project that we have, which is Project Jackalope, or otherwise referred to as the Hopper. This is a vertical takeoff, vertical landing vehicle, and the goal of this is to fly to 30 meters in altitude, do a couple of maneuvers, move left and right, and then land back down where it came from or at another position that we give it. We want to fly this by 2026, and that's quite an ambitious deadline. So to cut development times, we're going to reuse the Nova 2 engine that we use for the Ignis rocket, also for Jackalope. But as I mentioned, we're just going to implement a couple of changes and add a bit more functionality so that we can work with it better. Of course, this is, as I said, a very ambitious deadline, so we need to take a couple of baby steps beforehand, and that's where the Hopper demonstrator comes in hand. Within the team, we refer to it as Tapetti, and essentially it is a small-scale testing platform for the rocket, and you can see it right here. In other terms, it's just a drone with a propeller on the bottom. You believe it or not, it mimics a rocket exactly when we speak in dynamic terms. And the goal of this is to make it fly, make it stabilize itself in the air, do a couple maneuvers just like the Jackalope rocket would do, so move left and right. And so we basically tune the control algorithms, guidance and navigation algorithms, implement all the sensors, validate our design. And once we are sure this works, we combine it with the things we learned from the Ignis rocket. And then we are pretty confident we can make the Jackalope rocket fly as well.
Thank you.
Thank you very much.
Any feedback from our astronaut guests?
Well, congratulations. I think that's very interesting and ambitious. And you have a test program, progressive test program to test each level, which is perfect. So I think it's a wonderful activity for students, especially those who are not used to working in the space industry. This is a perfect way to introduce people to, flying in space, is to design rockets. We have competitions in the United States, the Student Launch Program, and I've been to some of those events. It's very exciting. They have a specific target and an altitude that they're reaching, which I guess you do too. And they have to be able to recover, the payload that they're carrying. So they're not just doing rockets, they're carrying a specific experiment also. So I think it's a wonderful opportunity for students to be involved. So good luck.
Looking at this nice baby here, I have the question, why is the propulsion, the propeller, at the lower spot and not at the upper spot? For the flight dynamics, I think it would be better to have it the other way around.
I mean, we want this to mimic the behavior of the
propulsion
vehicle that we have, Jackalope.
Okay.
And obviously that has an engine on the bottom. We want the fiery end to be down below. So that's why I implement the propeller on the bottom.
Thank you. Makes sense.
Thank you very much. And I just want to mention, this is a perfect example of from dream to demo, which is the motto of our innovation space, which is basically a center for student entrepreneurship and innovation, which is sponsoring this event. So can we have another team coming? Team Aster?
Hello, it's me again in a different shirt. So we're actually participating as Aster. My name is Ferris. I'm currently the team manager. I'm here together with Maria and Daniel. And we as Aster are the first student team in Eindhoven that tries to build its own satellite. But we're also far more than that. We also try to make a vision come true, which I just pitched, and is bringing that spaceport closer to Brainport, or just building the space community within Eindhoven. We're a relatively young-ish team, I think, 3.5 years old. We're currently with 25 enthusiastic students with, I think, over 13 nationalities of both bachelor students and master students, from Fontes and to UE. So the goal of our team is to promote space engineering and education in the region. Well, how do we do that? We do that through a couple of events. For example, by organizing space events by itself. We also have one today, a Studium Generale lecture, so please, if you want to come, you can still come, I guess. And also technical projects, one of them being satellite development. This past summer, we've already, which I will show you in a different slide, done something quite great in my opinion. Always makes you emotional. I will show you that on the next slide. But we do that as well. Once we have our satellite, hopefully in the future in space, we would like to communicate with that as well. Well, how do we do that? Well, hopefully, somewhere on the campus, we are allowed to build our own ground communication station. And if that works, we'll allow all students and the faculty to make use of that facility such that we can give an educational return to the university. One thing that I want to make clear is even though there's no aerospace faculty at the university, there's all relevant knowledge available here. So each bachelor with their own background can contribute in a unique way to satellite development or just space industry in general. So what did we do actually? So we started, I think, with around 6 people, and we made a small suborbital project, as you can see here on the left. The idea was that we measure radiation in some novel way, and it would go in a suborbital rocket and would come back, and we did something amazing. It went to the rocket, then Corona came, and it wasn't allowed to launch anymore, so we got it back. But hope wasn't lost. We then continued with our ground station. How do you communicate with, let's say, our satellite or with just open satellites in general? That's something we're doing now. But at the same time, as of this summer, we finished our first prototype for our satellite, which we launched with a high-altitude balloon above the UK, of which I would like to show the footage now. So yeah, this always makes me really happy. But I guess for astronauts, you've been higher, but maybe you've been here also, I don't know. But yes, so that's what we did last summer. We built a prototype of what our satellite will eventually be. We put that on a balloon such that it will be retrievable. And we retrieved it. It landed in someone's backyard, but we were able to retrieve it. So that's amazing. So where do we stand? We just finished prototyping our first satellite, and what we will do is at the end of this academic year, we will have finished the complete design of our satellite and we'll start building it next year. Then somewhere around 2026, we will launch our satellite, and in the meantime, we'll try to work together with the faculties of this university and companies in the region as much as possible to bring that information and that knowledge to Eindhoven, Brainport, and the university in general. So some of our partners next to Innovation Space, so hello Innovation Space, we're also work together with the European Space Agency, ESA, the Dutch Aerospace Center, and today we have an event organized together with NSO. So if you'd like to know more about what we do and what we're going to do, please follow us on our social medias, and thank you for your time and attention.
Oh,
Yes, oh yeah. I forgot to.
Can we hear your opinion about their projects?
Well, you're building rockets and now you're building satellites and ground stations. That's fantastic. It's getting everybody excited about going to space. I mean, seeing that view is amazing and gets people excited about it. So CubeSat is a fantastic program. We have launched many CubeSats, and it's a good way for students to design experiments, satellites, payloads to go into space. And so I'm excited that you're going that route, that you have that as a goal for CubeSat. I guess on Artemis, is that where you're launching it? What's your vehicle for CubeSat?
We don't know yet, but
you don't know.
The idea until now is if we finish by the end of this year, we may enroll in the Flyer Satellite Program from ESA, the Space Agency. And I think that will be, where is it on the equator? Somewhere at
Or from Swedish sport.
French Guinea, yeah.
Okay.
But to be determined.
I would encourage you also, and the rocket builders as well, to tell young children about that and share your launches or your results from your satellite with school children to get them excited about space as well. Yeah. Good luck.
I'm not so sure whether I understood everything. The ground station you are developing is a ground station to receive signals from orbit, correct?
Yes.
Okay. But if you run a satellite, okay, I mean, depending on the orbit, of course, Earth rotates underneath. So, I mean, how, percentage-wise, how much time of the 24 hours you expect to be able to have contact to the emitter, or let's say to the object in orbit, to the CubeSat or whatever? I mean, one ground station on the ground doesn't give you not that much chances to establish what is called, how's it called, acquisition of signal.
Of course, it depends on the orbit, but this will be only part of the communications. So we'll lose our ground station for only part of the communications. We use external ones for the other part. So we expect to have 100% coverage throughout the whole orbit, but this will be only part of it, of course.
Okay.
Yeah, the main reason for the ground station is to create a platform that the university can use for other things. So we can put different antennas on it. We can put a radio telescope. It's more of the system itself.
Oh, okay, okay.
Thank you very much. And I just want to take this opportunity to thank our amazing workshop support, Edwin and Hob, who support all these students. We bring guests to see our workshops and 3D printing and other labs, and everybody's impressed. So if you have time, we would like to show it to you as well. But we apparently have, at the level of a serious space company, we have good labs. And of course, at the heart of all technology are people. So Hub and Edwin support our students, and Mark as well with all the safety checks. So we have a really nice team supporting the students and a lot of potential to grow. So the potential to grow will be further presented by our NSO guest, Yus Karpai, and he will present what is next after this.
Well, to be honest, good afternoon, everybody. First of all, thank you for all this. I think we thought space would be inspiring to you because of all the challenges, but it also works the other way around. You inspire us in the space community because we see all your ideas and we see your enthusiasm, and we want to keep that. So I can't tell you very much about the Space for Talent program because there is no program yet. So that's reasonable, right? So I think, but we noticed the past, 7, 8 months that there's a lot of ideas with students, there's a lot of enthusiasm, and we must keep that enthusiasm because space is really very important. It's in our lives every day. So this whole idea of space being up there and very lofty, and we send astronauts out. No, we use space every day. We use it for navigation. We use it for Earth observation. We use it for our own security and safety. And we need your talent and the talent of the people after you, the students after you, to feed into space. But we also need space to make sure there is sufficient talent. And for that reason, we have a Space for Talent program that we want to develop to make sure that events like this are not just a one-off, but that we keep feeding into our community your talent, that your talent also is used in other places in society so that all this inspiration is not lost. So thanks to your enthusiasm, we are now thinking hard about how to do this, how to do a Space for Talent program, and actually it's Space for Talent, Talent for Space, so that we can continue this. And if you have any ideas on how to continue this, what should we do again, what should we do better, what should we do never again, that's also a possibility. please let us know, and we will, the coming months, start thinking about, or develop our thinking about this program and develop it further, and with the help of our ministries, we will implement it, and I'm sure that we will see some of you back. I was very happy seeing this. Some of your ideas were a bit scary to me, to be honest, this engineering of the human body to make drugs. I'm sure there are some people who are very interested in that, but that's a different story. But ideas start in a very interesting way, and let's see what comes of it. So I look forward to hearing more of you. Thank you.
Thank you very much.
Additional speaker already getting, wow.
That's an innovation chocolate. It brings you eat it and all the innovation comes up.
Ah, okay, I needed it until now.
Yeah. Well, this brings our program to the end. So for the final words, we will ask our astronauts, what would you like to leave audience with? Some inspiring words from all your experience and your future insights.
Well, first of all, I'd like to say I appreciate the innovation and the enthusiasm and the great ideas, because you're thinking, out of the box, if you will, in some ways, and that's what we need for the space program. We really need to innovate and solve these very difficult problems about going beyond where we've gone before. So I'm so happy to see so many young people interested in solving these problems. So I'm encouraged by that. I don't know if I have anything to say based on my experience in space, but my experience in life has told me that a couple of things that I would encourage you to do. One is not give up. Keep trying. Engineering and science and testing will result in some things not going as you expected. So learn from those and move on and do better the next time, but also for yourself. I didn't get selected to be an astronaut until my third try. And so each time I tried to think of ways I might improve my chances, but I wasn't going to give up. And I think that perseverance is important. Also, the path to your goal may not be a straight one. Some people think, oh gosh, you must have always known you wanted to be an astronaut and you did this and did that and it happened. That's not the way it works. For one thing, when I was a young girl and in college, we didn't have women astronauts in our country. We were all military test pilot astronauts, male at that time test pilots. Now we have female test pilots, thankfully, so I didn't even think about that. But I was inspired to go into engineering because I grew up in Huntsville, Alabama, where we were designing the Saturn V rocket. But even so, I started out in engineering, and then I decided I wanted to do biomedical engineering, so I went in that direction. And then there were no jobs in biomedical engineering, so then I went mechanical engineering. I started out in the petroleum industry because there were no jobs at NASA. We were in between Apollo and Shuttle, and there were no jobs. And so I worked in the petroleum industry. But I used my biomedical engineering in space because we did life science experiments. I even used my petroleum industry background because we're looking at the Earth and geology and different things that I learned when I worked in the oil industry. And so it was a circuitous path, but I learned something each point along the way. So if you don't have a straight path to where you want to go, at least learn. You can learn from every experience, every job, and the things that you're working on. So don't be disappointed if the path you take may not be a straight one. So those are some things I've learned in my career and also in becoming an astronaut, to set a goal, not give up, and persevere, even though it may have some twists and turns along the way.
Thank you. What about you, Ulf?
Well, I couldn't agree more. But to make it very short, I'd like to recommend live your dream. I mean, if you have something in your mind, what you really want to do and what you really enjoy to do, just go for it. It doesn't need necessarily to be linked to space. It could be music or whatever. But anyway, I mean, do something which makes you really happy. And I think, yeah, it may happen that you stumble, you fall down. What matters then is to stand up and continue. To come back to the space program, which is only one option, I think the big challenge is actually now for you young people to continue what our ancestors did with their ships. They moved to all kinds of unknown areas, and the Dutch were real, very famous explorers. And now we are all challenged to continue what they did with our ships. And the obvious goal, from my personal perspective, is to go to Mars eventually. And there are so many interesting questions we have to solve before we actually can do it. If you go to Mars, you have to run your spaceship as a wall such that it runs in a closed loop. And there are so many problems. Take water as an example. You should have 2.5 liters water per day, roughly speaking. So if you have 6 people, that means 15 liters of water per day. So that means in 100 days, you need 1.5 tons of water. If it is 1,000 days, it's 15 tons. So in other words, we do it already. You have to recycle the water and many other things. And these life support systems have to be extremely robust because the entire life of the crew depends on their functionality, on their reliability. And I think these are the big issues I'd like to leave with you. Find the solutions. It will be very interesting and very rewarding.
Thank you. That's a very nice sentiment, that we want to go in space because there are interesting challenges to solve and because we're a curious species. We want to know the answers. So thank you all very much, and thank you, audience, for coming.